welcome to a little video on scientific notation. Now, just to refresh, scientific notation means that we will have a number times 10 raised to another number. And this beginning number must be between 1 and 10. It's going to be a single digit. You could have a decimal with stuff after it, but the leading digit must be single there. And your exponent can be positive or negative. If it's positive, it means we have a big number, more than 1, well, more than 10 really. And if it's negative, we have a small number, small meaning less than 1. So if we look at examples 1 and 2 here, we have two numbers in standard form, and we are going to change those to scientific notation. Now, we see that these are both numbers that are bigger than 1, and therefore we are going to have a positive exponent. So, in number 1, the first thing I want you to think about is, where do you see the decimal? And if you don't see a decimal, right, that means it's automatically at the end. So our decimal's at the end. Now, we need to change this number so that the first number is between 1 and 10. And hopefully that's pretty easy to think of. Well, if I would just put a decimal after the 4, then my first number is 4, and that's between 1 and 10. So I would have 4.56. I have to have all non-zero digits in my beginning number, times 10. Now, how do we determine the exponent? The exponent is determined by how many places you moved that decimal. So, I'm going to move that decimal 1, 2, 3, 4, 5, 6 places. So, times 10 to the 6th power. In the second one, hopefully you can see that the decimal's at the end, and I want to move it between the 5 and the 4. So, 5.43, all non-zero numbers, and I moved my decimal 1, 2, 3 places. So that number will be 5.43 times 10 to the 3rd. All right, moving on to the next page. Now we have scientific notation, and we want to change that to standard form. So your exponent is still going to be the keeper of all things decimal moving. So because my exponent here in number 3 is a 4, that means that my decimal is going to move 4 places. And you have to determine whether you're going to move to the right or to the left. Now, in this example, my exponent is positive. Positive means my number is getting bigger. Number getting bigger means my decimal moved to the right. So I'm going to start with my 8.3, and then my decimal is going to move 4 places. 1, 2, 3, 4. What goes in those mystery bumps are zeros. So 8.3 times 10 to the 4th is the same as 83,000 in standard form. So now let's go ahead and let's look at this, where I have 6.201, and I'm going to move it 5 places. So my decimal goes 1, 2, 3, 4, 5. And in those 2 humps come zeros, so I have 620,100. And there is going from scientific to standard. So the exponents really are the mover of all things decimals. All right, now let's multiply. When you are multiplying with scientific notation, we kind of do this in 2 steps. So you take your first number. So I'm going to take 3.8 times 5.7, and then we will take our 10 to the 8th times 10 to the 5th. So when I multiply these 2 numbers together, 3.8 times 7.5, I will get 21.66. And when I put these together, hopefully you remember when you multiply same base, you add the exponent. So 8 plus 5 is 13. Now, right now, I hope that you're like having a little fit here, because you should notice that this first number is not between 1 and 10. It's 21. It's a big number. Big number means our exponent should get bigger. So I'm going to go ahead and move my decimal 1 place over, and that means my exponent will go up by 1 place. Big number, decimal goes up. So my final answer is 2.166, that's not a very good 6, times 10 to the 14th. Because I had 13 and then I went up by 1. Let's go ahead and do a division problem. We are now going to take 2.3 times 10 to the 7th and divide it by 7 times 10 to the 3rd. Now, same basic idea that you do it in pieces. 2.3 divided by 7, this should be, oh gosh, I have typos all over the place. This should be a 7.9. So if I take 2.3 divided by 7.9, I get 0.291139 times 10. And remember, when you divide, you subtract your exponents. So 7 minus 3 is 4. Now, once again, hopefully you look at this answer and you think, yep, that's not right. This first number is not between 1 and 10. It's a small number. Small number means your exponent is going to go down. Small, down. Big, up. Okay, so I need to move my decimal one place to get my number between 1 and 10, and therefore my exponent is going to go down by 1. So my final answer would be 2.91139 times 10 to the third. And really, if we go based off what we had before, two significant digits, we could just have 2.9 times 10 to the third if you deal with significant digits. All right, I would like you to try these two on your own, so just hit pause, try multiply, divide, come back and check your answer. Okay, so when you multiply in letter A, you get 22.814 times 10 to the 10th. Well, 22, right, too big. So if we move it one place to the left, your number is big, so your exponent will go up, and you end up with 2.2814 times 10 to the 11th. And in letter B, when you divide 5.6 divided by, divided by 5.7, you'll get 0.9825, and then times 10 to the second. Because your number is less than 1, you will move it to the right. That moves your exponent down by 1, and you get 9.825 times 10 to the first. And yes, I did round in letter B. That one goes on, I believe, for quite a while, but I was running out of space. So there is your little video on scientific notation.